All right. Good evening. Hello, everybody. I'm so glad you guys came here instead of going to the reInvent party or getting ready for it. So appreciate you coming out here and learning about networking stuff. I'm Nick Matthews. I'm a product manager. I'm the product manager for CloudWAN. Santiago?
I'm Santiago Riesco. I'm a product manager for Direct Connect.
And so today we're talking about the new stuff. This morning we launched both CloudWAN. Oh, I need to press this button, don't I? Yeah, I do. Cool. Yeah, so we're here for AWS CloudWAN as well as Direct Connect SiteLink. So we're going to talk a little bit about why we built these services, how they work, et cetera. You're in for a fun-packed ride with 110 slides. So we're gonna get through it today. So, yeehaw! I'm just curious about the audience. How many folks are networking people? Okay. How many people are like developers or non-networking people? Okay, handful. So usually about 50-50, more networking folks. And how many folks are using Transit Gateway today? Okay, so most folks. What about Direct Connect? Okay,
All
also
right.
most folks. All right,
Yeah.
So we're talking to our people here. That's good news.
Yeah. All right.
So a little intro here. So we have the AWS global backbone and AWS infrastructure. We've been building out our infrastructure iteratively over the last 10, 15 years to meet the needs of what we need to do for customers, right? So this is the same backbone that we use for Amazon.com, Prime Video, all the data center needs and sort of data center application type stuff that we do in between regions. And so, we're at 25 regions. We have things like accelerated VPN, where you can terminate VPN at our edge locations and then go into a region from there. We have 96 of those locations and over 100 different Direct Connect locations. And over the last, especially last particular few years, as more and more applications are in the cloud, and sort of that center of gravity has shifted from being in data centers to inside AWS, customers are telling us like, hey, we're buying all these networks and MPLS networks and fixed circuits that are basically just tracing your backbone. And we don't really think that's a great idea. We'd like to just get it from you, use your backbone. Can we use you as a WAN? It's starting to come up a lot more recently. And so, what that looks like is they go, hey, I just want to choose a couple locations that are close to me, whatever my sort of footprint looks like, maybe globally or nationally, and then build my own private network over those locations. And so what would that look like inside of AWS? And so from here, you attach your data centers, locations, movie theaters, engineering sites, whatever it might be. Because security is important, you also want to be able to do things like segmentation. And so you also want to then break those things out into separate networks, the engineering network or the prod network or whatever it might be, sort of globally. And so between me and Santiago, we're going to sort of show you how to do that in two different ways with the services we've released. So Santiago, why don't you start with the Direct Connect stuff?
Absolutely. Thank you, Nick. Hey, everyone. It's really great to be here. I'm super excited to talk to you about our new feature, Direct Connect SiteLink. So to talk about SiteLink, we first need to talk a little bit about Direct Connect. So let's do a quick intro. Direct Connect provides a way for you to physically connect to the AWS backbone network. So we are in over 100 locations worldwide, and you basically physically connect to us, and this provides the best way to get your workloads in an AWS region. It is the best path because basically you avoid the internet, so you avoid bad internet weather here. It's also very flexible. You can choose between hosted connections or dedicated connections that go from 50 megs per second all the way to 100 gigs per second. And with pay-as-you-go pricing, basically you pay for consumption. So it's very flexible. You can use it. You only pay for what you use. So this is a little map. As I said, we're in over 100 locations. We are, I think, now in 32 countries. So we have a very large global presence. So for you that may not be as familiar with Direct Connect, this is what the most basic configuration looks like. So you have there on the right your data center or your office somewhere. This could be anywhere where we are located. Then you connect to one of our points of presence. We call these POPs for short. And then using a virtual interface, or VIF, you attach these directly to a VPC, and you have direct connectivity to your workloads. Then you can do something a little bit more complex. You can use a Direct Connect gateway to access multiple regions and therefore you can use the same connection to access multiple workloads in multiple regions. Then you can do something even more complex. High availability with multiple connections using a transit gateway. But in all these setups, traffic flows usually, or in all cases I should say, from the region to your on-prem network. This is true for all the configurations I just showed. So I got it. Direct Connect is awesome. So what is Sitelink? So at AWS, we talk to customers a lot. You might have heard our usual quote that 90% of our products are designed and developed working backwards from what we hear from customers. So we talk to them. And some of our Direct Connect customers are operating private networks, global private networks, and they're facing some challenges. First off, they might face challenges when crossing to different geographies. So some of them might have a great network with a great provider, say in Europe, and another great network in Asia Pacific somewhere, but then interconnecting those two networks becomes a challenge. Turns out there rarely is the case that a single provider is in all locations. Then we found out these networks are very rigid. So they're bound by long-term contracts usually, and if you need to add a new location, it's slow. If you need to increase or decrease your capacity for peak season or anything like that, it's very slow. You need months to change. So all of these can make the network very expensive to operate. So what we're hearing is global presence, flexibility. We can help here. So today, we're introducing Direct Connect Sitelink. Sitelink allows you to route traffic between any 2 or more Direct Connect locations anywhere in the world using the shortest path over the AWS backbone. You can turn Sitelink on or off with a very simple configuration change. As we will see, it's really simple and it only takes minutes. And since it's built over on the X, I should say, it takes advantage of our global presence. So you can connect to any POP in any of our locations and then interconnect your on-premise network to any other Direct Connect location, and you're good to go. So how does it work? Direct Connect today, as I mentioned before, is the best way to get your workloads in a region. But until Sitelink came out, you couldn't do this. You couldn't route between POPs and therefore between your on-premises networks. With Sitelink, we're changing this. We're allowing direct routing between 2 or more locations using the Direct Connect Gateway software object that many of you, I'm sure, are using already. And you don't need to make any changes other than turning Sitelink on or off. So again, as it's built on Direct Connect, it takes advantage of all the benefits that Direct Connect has today. So it's very fast. It goes over the shortest path over the AWS backbone. So we heard from customers that they have latency-sensitive workloads, even up to 2 milliseconds. So anytime they can save, they'll take it. So we feel Sitelink is for them like the best approach here. Also, it's very easy to deploy. If you are a DX customer already, as many of you are, you can turn it off in minutes. You can take advantage of the flexible port speeds, so you can right-size the connection to any location. So you can have an HQ with a 100 gig connection, or you can have a very small branch office with 50 meg. That's okay. And it's available today in all Direct Connect locations, except those in China. So this is basically how it works. This is the most basic diagram of how interconnection works. So you have one location on either side connected to a point of presence that could be anywhere, London, Hong Kong, the US, you name it. And then using the private or transit virtual interface, you attach those to your Direct Connect gateway, and you're good to go. Now, you can use the same Direct Connect gateway to access your workloads in AWS right now. And if you're comfortable with whatever setup you have today, you don't need to change it. You don't need to rip anything apart. You just enable Sitelink, and what Sitelink provides is that part there. That's it. You don't need to make major changes. So this is how you enable and disable it. On the left side, we can see that you can basically create a new VIF with Sitelink already enabled. On the right side, this is what you would see when you are editing the settings for an existing VIF. You can see there, it's kind of tiny, but you can see it says Sitelink Enable, and that's it. You're good to go. For those of you who are using the CLI or the SDK, that's more or less what it's look like. And now let's go over some use cases. So over here, we have an HQ on the left side using a very fast 100 gig connection. And then we have multiple offices on the right side using different connections of different speeds. Now, using a single DX gateway, you can attach the virtual interfaces from all these locations, and you can create a mesh network in minutes. So all locations will be able to talk to all other locations. A different design, say the HQ wants to be able to talk to each branch, but they need the networks to be separate. They don't want the branches talking to each other. That you can also do very easily. You just use more direct connect gateways. You can have up to 200 direct connect gateways per account. So basically, you can grow as much as you like. Now, let's talk a little bit about pricing. We are introducing 2 new pricing dimensions. One is per hour for each VIF on which you enable Sitelink. So basically, when you enable Sitelink, you start a clock, and you get an hourly rate for that. Prices are already published in our public website. Then you get charged for data transfer between the different POP combinations. Now, this what was a bit of a challenge. So basically, we created, because otherwise, like we are in 100 places, right? So creating a table that's 100 by 100 and you finding the exact POP, that kind of is a bad customer experience here. So we group them. We group them by geography. So if you're going from, say, any POP in the US to any POP in Europe, you'll get a single price. And that's per gig. And we only charge once. So the account that owns the virtual interface that's receiving the data gets charged. So only one way. So talking to customers, we got some questions. Let's go over a few of those. We're supporting IPv4 and IPv6. We have the same quotas in place that we have for Direct Connect today. So basically, 50 virtual interfaces, 30 VIFs per DX gateway, 100 prefixes per VIF. Those are still in place. QoS, another common question. AWS or DX in particular doesn't provide a facility to manage QoS. However, we will preserve any QoS markings that you use. So basically, you can configure QoS between your devices. So this is especially useful if you have, say, something like a 100 gig connection on one side and a 1 gig connection on the other side. You might want to configure QoS on your end. Also, where supported, MACsec works. MACsec works on layer 2. So basically, if you're using it, you can continue to use it and it'll work. Can I influence traffic? Yes, you can. If you want to have a configuration like a primary and a secondary backbone, maybe with a third-party provider, you can influence traffic. You can use ASPath, BGP communities, and set local preferences to influence how traffic goes between both connections. Another question, will I lose connectivity? And the answer is generally no. However, there is one case where if you have 2 virtual interfaces on the same AWS device, you will see a BGP flag. Other than that, you won't lose connectivity. So basically, if you have connections in different locations around the globe, you won't lose connectivity. Now, how do you determine if you're on the same device? Good question. Basically, using the CLI or the SDK, you can look for AWS Logical Device ID, and that's a unique identifier. And you do that for all your connections, and that way you can determine if you're on the same device. And this is what it looks like on the DX console. Basically, you get the number. It's EQDC2 is the location, and then you get a code, and that's how you determine if you're on the same device. If you're not on the same device, you can turn Sitelink on or off and be good to go in minutes. So that is Sitelink. I'm really excited. I'm looking forward to seeing what networks you create with it. And with that, back to Nick.
Right on, cool. Thanks, Santiago. So yeah, we're going to talk about the same problem with kind of a slightly different lens here. So we're going to go back a little bit and talk about wide area networks. I mean, it's in the word Cloud WAN, so I have to put this acronym in here. And so this is kind of what we think about with the sort of old school WAN in my mind, back when I was studying for a CCNA like a decade ago, more than that. Which is like, you're using MPLS and VPN. Users are in offices and applications are in data centers, which seems totally foreign now, but that was the case one day. And so it was pretty straightforward. And if corporate decided to roll out a new branch office somewhere, like it took months for them to do hardware, real estate kind of thing. So it took the carriers that long too, and it was no problem. When you started doing international type things and maybe you started scaling that out there, it also took a while. But again, if you had to get new contracts, new smart hands, new MPLS providers, these kinds of things, and it was okay. I think now sort of we're entering sort of a more modern version of this where the problems are different. So in this world, we have our network, but now we decided to move to the cloud. And so we started putting applications up inside of AWS. We've probably used something like Direct Connect or VPN to set that up, and that's, we've learned to do that, but it added a little more complexity to the network. Then we decided that we actually needed those applications in AWS then also needed to talk to each other, and we had to make a choice between TGW peering or VPC peering and Direct Connect and all these kinds of things. And this is the type of stuff we've been presenting on for years at reInvent. And then, there's all these other things that are coming up, right? So you've got client VPN and how do my remote users come in? Software-defined WAN, SD-WAN, right? There's a lot of benefits you can get from that, but it's yet another technology we have to add to the network. And you add these to each region you're in, and you have to figure out then somehow to make it work in with cloud. And so, what used to be somewhat simple, nice MPLS network, is now more of like a platform you have to run in multiple different locations sort of simultaneously, and adding a new technology or adding any interworking between these technologies becomes sort of increasingly complex, right? And then, like users are no longer in the offices, especially for the last couple of years, and applications are more and more somewhere else. And so it gets more complicated. And then you're not just in 2 regions anymore. Like now you want to go to a 3rd region. What does that look like? Well, now we got to get yet another location. We got to go figure out how to peer all those things, and how do we replicate our AWS environment to 3 places. We got to get even more smart hands, even smart locations. You get SD-WAN in there. Firewalls are all over the place. And I think when you sort of summarize this, when we talked to a bunch of customers about this, it was, the WANs are hard. So you're basically expected to do more use cases while the gravity is sort of shifting from data centers to the cloud, while users are all over the place, and you have to expand faster. But then like all the same rules of like the 20-year-old network still apply. Like it still has to be highly available. It still has to have, you need to lower the amount of cost in the network. And by the way, we also need to increase security while we're doing all that stuff. And so when I talk to customers, it's like, yeah, it's really hard. Like a lot of people are not very happy with their WANs right now. It's kind of what the feeling I got when I talk to customers about, especially when they interwork their current WAN with AWS. And so that's what sort of led us to introduce Cloud WAN. So this is the idea that you can build a global network in minutes, that we can simplify the amount of work it takes to use AWS's backbone, and that we can also still increase the amount of security when you're doing that. And so we can centralize, security and networking configurations in the day 2, so it's a lot easier to run these networks. And so I can tell you a little more in depth what this looks like. And so what we've got here is a Cloud WAN network. Again, let's from that last slide, we're running in 3 regions. This is what it might look like. And so you can come into the AWS network how you want. You can come in over VPN, Direct Connect, SD-WAN, client VPN, et cetera. You can attach those things per region into the Cloud WAN. You can also attach your VPCs per region. And so you're on one big sort of unified Cloud WAN network. Even though this is a WAN, one of the things that people want to know about is like, are we doing anything on premises? And the answer is no. So you're still using your existing telco providers or the existing CPE and branch offices, so your existing routers and firewalls. And you have to get to the AWS region. And then that's where we make all this sort of intermixing of those things a lot easier. So some of the use cases you can use this for, I put them in sort of 3 different buckets, and I'll sort of go into more details for each one. But we talk to some customers and they go, hey, look, we're running VPCs in like a lot of regions and it's hard. We're adding static routes all over the place and it's, our developers just want one big flat network, these kinds of things. We've got customers that go, I don't care about VPCs at all. I really, really care about your backbone. Like I really want to use you as transport between my branch offices and make it way faster and way easier to connect my branch sites. And then you got sort of like the both, like we're doing a little bit of both and we want to make both those simpler. And so if we actually sort of break these down a little bit, what they end up looking like is something like this. So people have asked us for a while for like a global VPC. I just want one big VPC networking space so my developers can play around with and they don't have to care which region they're in. So we just kind of sort of accidentally did that. So you can now just create one big flat network, connect everyone to it, and you don't have to worry about regions anymore. So that's nice. We can also do this, but with segmentation. So you can say, all right, well, within the same Cloud WAN, I can create a development sort of segment. I can create a production segment. We can do things like advanced automation. So one of the things that we've seen with customers when they build transit gateway networks is they spend quite a bit of time building things like propagations and associations and how to do API calls to map attachments to route tables and those kinds of things. And so a large chunk of that is all built into Cloud WAN. And so even if you're just running in a single region, for example, you may not want to build that automation. So we've got some cool things we've done around the sort of attachment and routing automation here. The other thing we've done here is, we see a lot of customers that need firewalls for security purposes. So you can still insert those things for east-west or north-south and whatnot. In terms of the WAN side of things, there's a couple different examples. So Santiago's talked about the SiteLink case, right? So SiteLink is really good for direct connect. You want to go port to port. If you care about the performance characteristics of going into a region or not, like SiteLink's probably what you want to look at. And so particularly if you already have DX ports, you enable one flag and boom, you're done. His presentation is way simpler than mine, so spoiler alert. And so that's great for doing port-to-port routing on your DX. And there's some other use cases for WAN only here. So for example, if you want to create transport for SD-WAN, and it doesn't have to be just SD-WAN. For most of the customers I talk to, they're in that sort of migration period where SD-WAN's like 10, 20, 30, 40, 50, 60% of their network. And so you can use SD-WAN for transport, but then you can also use VPN to the sites that you don't want to put SD-WAN in, or you can use Direct Connect for the sites that have higher bandwidth. You can also do things like, hey, I want to centralize all my internet egress out of AWS and put some Squid proxies here and use AWS as the internet provider in a certain way. And so you can set up your own VPC, create your security device and whatnot, and we can do that as well. And then when you have a little bit of both, here's some examples. So this is more of a common, simple one. Like, hey, we just want to do DR. Okay, well, you can set up yourself in one region, set up your connectivity, and then if and when you're ready to do the DR stuff, you can basically extend Cloud WAN to the other region without doing a whole bunch of rework, without having to copy a bunch of networking things and worry about peering and those kinds of things. So we can just dynamically do that. It's also the case of, man, it's just a lot of work to connect a lot of regions. So in this case, you just connect once and you connect to all the different regions sort of simultaneously. You also may want to do sort of segmentation with this. So you may want to say, I've got engineering sites and HR sites, or I've got company 1 and company 2 sites that need to connect to the WAN sort of separately. And so we can use the segmentation here as well to say that, like, yeah, there's a red stripe, there's a green stripe in the network. So these use cases, let's dig in a little bit deeper here. So the way this thing is sort of constructed is it uses the global network that we've already built in within Network Manager. So global network is a existing construct. You can register your transit gateways there. You can go in there and you can see the topologies and the events and the metrics and those kinds of things. And we'll talk about that later. But we're reusing that. So if you've already built a network manager with a global network, you can reuse that here. And so you can, then what you end up doing is you end up creating the core network. The core network is the demarcation of where AWS is going to do stuff to the network. So it's your global network, and the core network is the part where AWS manages that for you. And so that core network then has your segments in it. You create attachments, so VPN, Direct Connect, et cetera. You can also connect your VPCs there. The way it's managed is different. So what happens is you create a network policy. So that core network policy is one policy that defines your entire global network. From there, we take that network policy and we turn it in sort of that intent, and we turn it into actual implementation. And so in this case, what we end up doing is we put what we call a core network edge in every single region. So that's very similar to a transit gateway, except for it's managed by AWS. And we've also turned on some features and other internal type stuff that we can do. So it's not exactly a transit gateway. It's something similar. So a lot of things are going to look very similar there. But that's the routing infrastructure. You really don't need to worry about that very much, because that's, for the most part, that's just where things attach. You think about things in the policy instead. And so once those network edges are built, we then create a global network that's fully meshed across those routers. And so we're running BGP here. So this also means that if you advertise routes in one region and you want to access it from the other region, there's no static routing involved. So we've got dynamic routing across multiple regions here. We're also running monitoring protocols across these links so that we can tell you more about what's going on under the hood, performance-wise, on the backbone. And so this is all managed through Network Manager. So you would upload your network policy to Network Manager, and that's your sort of central point of view for everything, which we'll walk through what those metrics look like. So you guys may have seen me present this stuff before on Transit Gateway, and I'm wearing a Transit Gateway shirt, so I should talk about it. And so the differences here and why you may want to think about one or the other, which is Transit Gateway is really, it's not going away, right? People love Transit Gateway. I love Transit Gateway. And so it's really more about, hey, you've got full control over it. It's a regional object. You can do all the flags and automation. If you've already built your own automation, you may not need this, but maybe you don't like maintaining it. So the Cloud WAN with the core network edge is the more managed version of that. It's going to inherit a lot of things from Transit Gateway. So the same designs that we've presented on at reInvent on firewall insertion and client VPN integration and centralized services inspection, those things all pretty much directly apply to Cloud WAN, including the way that you would end up doing like multi-region type stuff in some cases. And so it's really about a regional versus global and do-it-yourself versus managed. And so the way these things would actually interact is that in some cases you'll have this brownfield where like, hey, you have some things on TGW and sort of architecture version 2 is on Cloud WAN, and you start putting your new VPCs on Cloud WAN. At some point that turns into migration where you would actually probably want to move the VPCs from Cloud WAN for VPCs from Transit Gateway to Cloud WAN. And in some cases it's more of like a federation where like, hey, we're a big, crazy global company, and that's a merger and acquisition, or that's a business unit that I don't fully control, but they want to integrate with our corporate network. And so in some model, you can think of the Cloud WAN as sort of more of the cloud network, and all these sort of spokes are their own TGWs. And there's maybe no VPCs on Cloud WAN at all. So let's talk about the network policy a little bit. That's the cool part. So the network policy has 4 parts. The network configuration concerns the regions and ASNs, kind of like a physical topology. The segments, which are the layer 3 routing domains. So you give those names and they have defaults. You can talk about the routing functionality, so how routes should be shared between segments or if they should be at all, also static routes. And then the mapping. So we'll talk a little bit about how attachments get automatically mapped to segments through the automation that we've built. So inside the network configuration, and this is a snippet from the console, it's 2 main things. You define the ASNs so that we know how to set up the dynamic routing, and you tell us which regions you want to be in. If you're using the Connect protocol, mainly for SD-WAN, we do need some CIDR ranges for tunnels, but it's optional. What's cool about this is once you define this, if you define 3, 4 regions, whatever you want, and you want to go to 5, 6, 7, 8, 9, 10, you just add those more regions. You don't have to do any regional specific configuration in order for that network policy and those configurations to extend to those regions. The segments, like I said, these are layer 3 routing domains. So when you create a segment, it's like a global VRF or IP VPN. So it's a layer 3 routing domain that's set up globally. Places where you would use this are, software development lifecycle, dev, prod, shared services, tenants, company 1, company 2 that hates company 1, things like the office types, engineering, HR, whoever hates HR. And so you can set different settings on these. So for example, you can say, I'm a network administrator and the sandbox segment, I don't care who joins that. I don't ever want to be contacted about joining the sandbox. I don't care who's in it. So you can just turn auto accept off. It's on by default. You can also turn on isolated mode. So isolated attachment mode is when you go, maybe I do have the sandbox and I don't trust people in the sandbox not talking to each other. So I don't want them, I want 1,000 VPCs in the same segment, but I want them to be able to talk to each other. So you turn on isolated attachment mode, and then you can't talk to each other within the same segment, which means you're probably sharing something from a shared services or on-premises or something like that. But you can set that up. And then you can also explicitly limit the regions. So this allows you to do things like, say, I've got an EU development stuff, and I don't want that to go into the US or Asia or something. And so you can set that up so that it's only in certain regions. And you can even further lock that down in the policy and say that, like, no, actually, I only ever really, really want these things to talk to each other. And you can set that explicitly in the policy that it's like locked in sort of even more explicitly. Within routing, we've got two different ways to do routing. So the sharing allows you to create a relationship between segments. So a segment is a group of attachments. So a relationship between segments is a group of attachments can talk to a group of attachments. And so we mutually do that. And so as you add more attachments to it around the world, you don't have to worry about what that grouping and what that union of sharing looks like. We just handle all that for you. And so in this case, shared services wants to talk to development. What that means is now this one shared services VPC can talk to those other two. So what's important is it's not from attachment to attachment. So you're not defining any attachment level things, it's groups of attachments. And then we can also do static routing. So this allows you to do things like firewall insertion, it lets you do things like black hole routes, it lets you do things like work with things that don't support BGP, and those kinds of things. The attachment policies are pretty cool, so we'll spend a little time on this. So in this model, we have a VPC, we have a core network, we have 3 segments. The network administrator owns the core network. And then maybe the VPC is someone like a business unit that wants to connect, and they're not sure exactly what they're going to connect to. So the way it actually works is, in this model, the VPC connects to the core network. It doesn't connect to the segment, right? There's, like, for example, there's no ARN for a segment. There's no ARN for the core network. The core network is the only resource in this model. The rest are figments of PowerPoint. Now, I'll show you what that means later. But so you create an attachment to this network. So you do the same thing with Transit Gateway. There's an attachment ID. And then from there, the cloud administrator needs to figure out what they want to do with that attachment request, which segment it needs to go into. And so in this case, we're not manually doing that, or we're recommending not to. And there's automation to automatically figure out which segment to go to. And so the way this works is you create an attachment policy that, for example, says, hey, let's look at the tags of that attachment request, and then put it in the right segment based upon those tags. And so in this model, we actually say if it says environment production, then we'll put it in the production segment. And so in this case, the attachment actually has that tag on it, and so we'll then go map it to that automatically. And so this kind of lets you do like a self-service model, where you say, hey, I can share the tagging models that I want to support to my developers, and they can tag things, and they can change them. And in some cases, I'll approve it, in some cases I won't, and sort of all that workflow works. Or maybe you're the network god, and you just don't have to approve your own requests. As you just turn off approval everywhere, and you just change all the tags manually. So that also works. And so in this model, it's important that we don't care about the VPC tags. VPC tags we don't look at. So whatever you do there, your business. So the attachment policies themselves have a number of different conditions you can use. So you can use the resource ID. So if you just really don't like tags for some reason, because they're too dynamic and too fun, you can just say, all right, I'm going to go manually save VPC IDs and put them into segments. So you can still do your manual style stuff if you really like it. And so you can do ands and ors, and you can say, like, yeah, if it's in this region or this account, it has this tag, you can do these kinds of mix and matching. So I'm actually really interested to see what customers do with this, because I think it's pretty powerful. So so multi-account support. So I mentioned a little bit about the sort of the VPC owner and the VPC admin and how that might be different. And so we support Resource Access Manager, like we do in Transit Gateway. This allows you to basically share the core network and Cloud WAN across multiple accounts in your organization. So in the console, this is where it looks. Inside the Resource Access Manager console, actually, so there's a new resource type here called Core Networks that you can share. We worked with the Resource Access Manager team to get this supported. So this is actually the first global object you can share within RAM. So there was a lot of mutual work that went on there. You guys may not care, but we think it's pretty cool. And so one of the things that is different is if you're the CloudWAN administrator, you'll manage the attachments underneath the sort of attachment area in the console, underneath the global network. If you're someone that the core network has been shared to, you don't have privileges to the core network. You just know that it exists and you want to attach to it. You actually won't even know which segment you're going to end up on, but you can tag your request. And so that's a slightly different window than if you're kind of the receiver of a network versus the owner of a network. So in terms of attachments, we support some details here. So the VPN and Connect are just like they sort of are today. So you can advertise 1,000 routes to us. We can advertise 5,000 routes back. The sort of overall bandwidths haven't really changed. So 1.25 gigs per VPN tunnel, which you can then multiply out up to 50 through equal cost multipath if you just advertise the same route prefixes and whatnot. VPCs are up to 50 gigabits per attachment, so again, same rules there, and total support for 5,000 attachments. If you want to go over 5,000 attachments, I'd prefer if you talk to me first. So yeah, so the way so I've thrown a lot at you pretty fast, so let's sort of take back for a second and start to figure out this whole thing works sort of end to end. So I've got some VPCs, I want to connect them in 3 regions. What does it look like? So I go into Network Manager and I create my global network. That global network will have a core network associated with it. Next, I will then create a core network policy. Network policy, like I said, is going to really define the segments, probably one default segment to start, the ASNs, the regions I want to be in, and whatever sort of tagging strategy I want to use for my attachments. Then I will go apply the network policy, which I'll talk about what that means, of how you apply a policy. And then you'll go share the policy out with your other folks through Resource Access Manager, probably to your AWS organization, or maybe just a list of accounts or some mix of that. Then you create the attachments, and you start tagging them. And the one last step that's important here is you then need to go inside the VPC and create the routes that point to the core network. You may log into the console and say, I finally got a bug. I saw a bug. Because when you look in the route tables, you actually point to the ARN of a core network. It looks really foreign compared to IGW, VGW, TGW, and then like a 1,700 character ARN. That's intentional, and that's because this is a global resource. And so global resources mean you point to an ARN. So in your route tables, you'll actually point to an ARN of a core network. That also means that you have the VPC owner themselves have control over what gets sent to and from these networks and whatnot. It's also because we support 5,000 routes inside of the core network, and we only support 1,000 in the VPC, so there's a bit of a mismatch there still. So I've said some words that are kind of scary if you're paying attention. I said the word global, I said the word BGP, and some of you may recognize this. And this is the image I think of whenever people say those words to me as a network engineer. And the short story for those that maybe didn't get the joke is there was a large website that runs BGP, and they messed some things up, and they ended up on the news. And you've got this clueless reporter telling people bridging gap protocol caused the whole problem because now the whole world cares what BGP is for some reason. And no fault to this news station or the website that went down. Like, these are things that can happen, but this is like also what everyone's terrified of happening. It's like you don't want to be the company that ends up on this situation. And so it's not like they didn't do that one thing that you can prevent, because if there was one thing to prevent it, like they would have done it. And so there's multiple things you have to think about to prevent this. And so I'll walk through a little bit of what we've thought about to sort of help prevent the elephant in the room over here. So one thing is AWS has been very, very specific that all of our services, or most of all of our services, are regional. We do have a handful of global services, which we're joining those ranks. And so when you have a global service, you have to think about blast radius and outage and those kinds of things. And so the core network edges are still running a regional data plane, regional control plane of sorts. And And the network manager is just going to basically go touch those things. And so we still have those regional boundaries that we've been very proud of so far. And so what ends up happening is you make the changes in Network Manager. So you upload your network policy, you push it out, and it's going to push it out to each region one by one. And so actually when you make some of your first changes here, particularly if they're multi-region, you may see some time there. You may see it takes about 20 minutes for us to go deploy it, validate it, do all the sort of interworkings under the hood. So it's not quite as snappy as some of the regional services, but there's some reasons behind that. And then if for whatever reason, our global service has some sort of control plane issue, it's not going to affect the data forwarding in the regions. So because those are regional and we basically push the routing stuff information down to them, if our console, for example, goes down, it's not going to affect the data forwarding. The other aspect is within the region. So within the region, we're on the AWS Hyperplane platform, which I've talked about a couple times before. And so the way that Hyperplane works is when you create a core network edge, in each availability zone that you choose, we're going to end up deploying instances in every one of those fleet. Well, the instances are actually already there, but you get a little piece of a whole bunch of instances. And so what this means is that if a single instance goes down, you're not really impacted. You lose some fraction of some piece of bandwidth you may not even be using. It also means that if other people or other attachments are on that same fleet, that again, your shards, we call this shuffle sharding, your shards won't match another customer's shard. And so we've basically isolated the ways that failures can affect more than one customer. And so this has been pretty tried and proven with a bunch of services. So we've got high faith in sort of the regional and availability zone version of our high availability here. In terms of the control plane, so this is the other big one that causes a lot of problems with changes. And so you make a change. So in this case, we have an API to create a network policy. Once you create that network policy, we're going to go validate that policy. And then what we're going to do is we're actually going to validate and create a change set. So we'll tell you, per region, what things are changing, what mappings are changing, all the sort of details of what we're about to go do. But we won't go do it. And so what you actually have to do is make a second API call, or in the console, click a second button to go apply those changes. And so this means that you can have the change created on Tuesday, go to change review board, which is all fun and games, as they are. On Wednesday, get it approved, and then on Saturday at 2 a.m., you can actually go push the change. Or it also means that you could have a different IAM group and role that can create changes versus who can actually push those changes. So it gives you a lot more control over the blast radius and changes and whatnot. I mean, you're still running BGP under the hood. There's still things that can go wrong here, but we've at least enabled a number of controls to prevent that. So also on the day 2 side of things, we've done a bunch of things around the monitoring. So this is one of the customers' favorite things about Network Manager for those that have played with it. And so we've really sort of extended on the things we already built a couple years ago in terms of doing this for the global network. And so I would say there's 3 major topics here. So there's the topologies that we've built, so you can visualize what your network is and where things are, particularly as things get larger. The metrics, so that day 2 things happen. And particularly the events are pretty cool. So I'll go into these a little more detail. So the dashboard will show you basically which regions you're in, where things are at. You get a pretty graph, so you can show your manager why your AWS bill is the way it is because look how cool it is. And so then you've got the topology graph. So this shows, for example, that we're building the full mesh under the hood for you. You can then break that out to see where are my attachments, where are my segments, where are my VPNs, are they up and down, those kinds of things. You can also go into the logical view because the policies and the sharing relationships you can get between segments can get fairly complex from time to time. And so getting this in a graphical view where you can get your head around it as opposed to clicking around a lot in a console or API makes it a lot more sort of graphical. So in this case, you can see that we've got 3 segments. There's production and development. No one can read this probably except for me. And there's a shared segment, which is sharing to the other 2 segments. There's 15 attachments here, 10 attachments here. So I have a pretty good idea what's going on from a routing perspective. And then the topology trees, again, something we've had in Network Manager for a while. And it's just more of a kind of a slightly different view of it. It's a little bit more structured for folks that like that. And then on the monitoring side of things, so you can actually go in and see things like aggregate metrics per region, packets in, excuse me, packets in, packets out. You can see on a per attachment basis or on a per core network edge basis what's going on. So we also have some roadmap items here. So one of the things that we're doing is we're actually doing passive metric collection across our backbone. And so the goal here is to provide real-time metrics of what's going on in the metric on the backbone, or maybe close to real-time. So we can provide loss, latency, and jitter numbers so that when you get a Jira ticket that says, the network's causing my problem for my application, you can say, no, it's not. No, the network is exactly like it was yesterday, and exactly like it was the day before, and exactly like the day before, and you probably messed up your application again. You guys like that one, yeah. So we're working on that one. It's in progress. When we get generally available, we should be closer to be able to provide this to you, but we're pretty excited about this capability. The events are also neat, so you can come in here and you can get all the routing changes that are happening. So we were talking to a customer this week, for example, that has these piped into Slack so that they can know when their VPN routes change or anything weird might be happening on the network. You probably don't want to be in there if the routes are flapping, but most days it's pretty nice. You can also find out what's going on with attachments and your tagging and all the sort of events that might be happening in this sort of automated network. So I read all the feedback that comes in after these sessions, and people always ask for more geese. And every year I put more geese, and they ask for more geese. Someone asked for like laser beams. So there's a goose with laser beams. So this is also an opportunity to make sure you guys aren't asleep yet. So, but yeah, let's talk about how this integrates with other services, because you're using other things in the network, and let's figure out how it relates. And so TGW is sort of the obvious one to start with. So if you've got a TGW you're already using, you like it, but core network sounds cool because all the automation, you want to start there. This allows you to sort of do the brownfield and sort of make it work together kind of thing. And so you can set up your transit gateway, create a peering connection, and then you can also then create the route table attachments. So each route table will attach to a route table in Cloud WAN. You can make that as simple, as complex as you want. Maybe it doesn't match up to my sort of rainbow tables here, but if it's just one route table, it becomes pretty simple. And this is kind of like, you could be in this situation for a pretty good time. So we're not going to double charge you on the data processing, so you'll charge one data processing charge across this. So it gives you that bridge from like sort of last architecture to new architecture. So you also don't have to worry too much about the timing of like, oh man, I was in the middle of my transit gateway migration and now I got to do Cloud WAN, I'm not sure which one. Like, it gives you a little bit more leeway of like, you can go transit gateway and then sort of move to Cloud WAN on your own sort of time. The other model is like if you do want to migrate, what you end up doing is you basically attach the VPC to both. You still have that static route in the route table, and then you basically come in there and you change that route to point to the core network as opposed to the TGW network. And then you can sort of get rid of all the sort of transit gateway parts that you don't want anymore. So you can do that as well. So the other thing that you've got here is Direct Connect. So there's no native Direct Connect attachments into Cloud WAN yet. That's one of the things we're still working on for roadmap in 2022. But if you want to connect to Direct Connect Gateway and Direct Connect into Cloud WAN, you'll do that with the Transit Gateway attachment. And so the Transit Gateway attachment itself is still also a roadmap for next year. That's one of the things that we're planning for the general availability of Cloud WAN, is the support for Transit Gateway and transitively basically through the Direct Connect support there. The other thing you may want to do that I sort of mentioned is like, yeah, maybe you acquire a company that have a Transit Gateway. Do we need to fully onboard them into Cloud WAN? Maybe, but you could also just peer them, and then they can sort of act on their own sort of autonomously as well. And there's this also model of this of like, up front, like one of the things you could do, like maybe you've already got a fairly sophisticated transit gateway network, but you really want dynamic routing. When we have the peering availability, general availability, then you just peer all your transit gateways to Cloud WAN, you peer once, and the Cloud WAN sort of acts like a provider network. In that case, it acts as a PE, and you have a CE sort of network. And so you can peer in once, get all the routes, and then do that because we're supporting the dynamic routing within Cloud WAN. And so it's kind of a model where, again, that could be, you think about central IT and then sort of all the spokes that you may manage, or sort of a large company and whatnot. And so the other question here is around, okay, we just presented SiteLink, we're on stage together, like when did you use one or the other? And the answer is like, you could use one, you could use the other, you could also use both. And so what they're similar, where they're very similar, is like they both use the backbone, both support encryption, both support providing access to AWS resources, and they're both global. You pay for what you use. Cloud-WAN's a little better for if you want to use VPN plus SD-WAN, you may have a more heterogeneous mix of things. You want to connect those all onto the same network. On SiteLink, that's on a port-by-port basis, and that's how you manage that. And it's also, you can go outside the region. So Cloud-WAN does have a regional dependency, and you have to worry about that last mile and what you're going to do there, which could be Direct Connect in some cases. So they can work together in those cases. So we're working on sort of like the more native integration between Direct Connect and Cloud-WAN sometime in 2022. So in that case, the better together story is, for example, you create the Cloud-WAN policy, and then Direct Connect gets configured the correct way based upon the policy, which may include SiteLink. So yeah, if you're running AWS as a cloud and you connect to other things that look like clouds, how would you do that? So there's at least 4 different ways to do this. One is we supported IKE initiation last year. So it used to be sort of like a high school dance where we both would receive, but no one would send anything. And so last year we enabled that, and so we can now create VPNs to other things that look like clouds. And so that's good up to about 1.25 gigs of bandwidth, mostly because we support ECMP, but the support for that's not everywhere. And so for most of the installations I've seen, it's 1 tunnel or 2 tunnels. So if you want more bandwidth, then it comes down to Direct Connect. So you can hook up a Direct Connect up into Cloud-WAN, and then you can then pull that over into the other things. And a lot of the Direct Connect providers, for example, offer this as a service already. The other option is things like SD-WAN and overlays. So you can create those in all the places you want, and then that will create the sort of mesh. It's still instance-based networking, so you still run into a lot of sort of like 1, 2, 3 gigabit per second sort of limits. And there's some ways around that, and there's a little bit of trickiness that goes on, but for a lot of people, you click it in a console and it just sort of works, and unless you need a lot of bandwidth, which you're probably in the Direct Connect case anyways, it also works. The other option is just use the internet. Internet's great, as long as you just encrypt your stuff. And so sort of on this note, we've been working with a lot of the folks that are in your sort of wide area networks today. So both with the telecom providers themselves, so folks like Verizon and Swisscom, who are working sort of with us to make sure that Cloud-WAN is a good experience for both of our mutual customers. The system integrators that do a lot of both the solutioning and the architecture as well as like managing of WANs. And then the SD-WAN partners themselves, and the security folks, to make sure that like if you build a network using some of these third-party services, that their control planes, our control planes kind of see the same story, and it's easier for you to plug those things into our network. So we've made a lot of progress with those folks, and we'll have sort of more to show when we go generally available as well. So things to know. So this is a public preview. It does mean that you don't need to call me. You don't need to call anyone to use this stuff. Please don't. Just go to the console. Just use it. It's going to be available in 10 regions, or it is available in 10 regions. It also means that it's not totally recommended for production. So there's no control, there's no service SLA yet, and some things like that we're still finalizing. And so we're really we did this intentionally. Like Transit Gateway, we didn't do this with, right? But we know the WAN space tends to move a little bit more conservatively. People want to kick the tires a lot. It's a global service. So we really want to help all the customers and folks understand this stuff, and want to get feedback so we can help sort of shape the product as well. So our regions here, we've got regions on all the continents that we operate on. So you can look at the region list here. There's 10 regions. We'll have probably something close to double of this when we go into GA. That list is still to be finalized, but it'll be pretty much all the other regions. So if there's 1 or 2 favorite regions in here that you don't see yet, it'll probably be there in GA. Some of the sharp edges and things to know about. So I mentioned it earlier, but when I say tag your attachment, people think, I want to use my VPC tags. I go, no, there's an attachment ID with an attachment dash some hex ID. You tag that thing. They go, yeah, I'm going to tag my VPC. So don't tag the VPC, tag your attachment thing. It's within Network Manager. It's one of the Network Manager objects. Sharing is supported within one organization. This is more of a RAM thing than it is a control, that we control. And so right now, within RAM, you can share to one AWS organization and then a list of accounts. If you need to share to more than one organization simultaneously, you probably need multiple cloud WANs to do that. And so we tend to see this again because if you're running giant, large global networks, you tend to also potentially be like large corporate networks with like lots of different subsidiaries and things like that. We don't have cloud formation support or Terraform. I'm sorry, you can boo me. We'll have that again sort of as we get into GA. Just expectation setting around the network. So this is not a complete one-to-one relationship with the MPLS network. So, like Santiago mentioned, like there's no quality of service on the backbone links. We're not changing last mile connectivity. We're not doing any on-premises equipment, any of those kinds of things. When you start sharing routes, you share routes between the segments, not the attachments themselves. So if you start thinking about a world of like, oh, I have 1,000 attachments, 1,000 VPCs, and I have 1,000 segments, you need to group things. So I'll talk about our limits here in a second, but we only have 20 segments. So that's going to, I think probably the most thought design area where you'll have to think more of this is how you want to do your segmentation. So you may want to do, for example, one big flat segment, which is totally cool, right? Like there's a lot of use cases for that, even though I talk about a lot about segmentation. Or you might want to say like it's between business units or PCI and non-PCI. And so I think the hard part of this will probably be thinking about the segmentation strategy. As well as when you create the VPN, it's a little bit different now. So in the console, for example, you'll create the VPN, you'll associate it with a customer gateway, but you're not going to associate it with an endpoint like a TGW or a customer gateway, or sorry, a CGW. So in this case, you actually say not associated. And then when you go into Network Manager, you can then come and it will associate. So it's kind of a two-step process there. So the roadmap items, just as one clear slide so you see what's coming next year, one is the transit gateway attachments. That's the big one, because that gets you the brownfield, that gets you migration, and that also gets you direct connect routing support. The next one is the direct connect attachments natively. That's also coming next year. The performance monitoring, more AWS regions, and obviously the general availability. Some of the limits and quotas we're working with, 10,000 routes, 20 segments. So the 20 segments one is probably the one that I talk about the most with customers. The rest, honestly, we don't get into very much, and we'll see where that goes. But if you run into things, contact support and ask them. We can work through those things. The pricing, so that's always the question here. So it's going to look quite a bit like Transit Gateway. There's an attachment per hour cost. There's a data processing cost. The data processing cost is the same as Transit Gateway, so there's no issues there. We did add, however, a core network edge, so basically a per region cost that we've added. So that basically helps you with all the automation. It supports, for example, all the peering attachments and all the peering configuration, and covers sort of the cost of those things. And so, you go, hey, it's a global network. We're going to set up 20 of these across the world. You can do that, but if you're not using any attachments in those regions, you'll be paying for something you're not getting a lot of use out of. So you really just want to create the core network edges in the regions that you plan on putting attachments into. There's a set of blog posts we've both put out over the last day or two. So if you guys want to take a second here and snap a QR code or whatnot. So there's 2 blog posts. There's also a blog post on intra-region TGW peering, which is pretty cool, which is really the sort of the foundation of us doing the TGW attachments, like I said, as the next step here. So you can now peer your TGWs in the same region as well, although that is static routing. So that's what we've got. Thanks for coming, and thanks for staying late with everybody, and I appreciate it. We'll take questions up here at the front, so let me know and fill out your feedbacks and tell me what you want to see next year. Appreciate it.